Hello dear NEET aspirants, welcome you all to another session of Brilliance NEET Crash 2023 40 Days Challenge. Get ready for a rapid revision of chemical kinetics for your NEET exam. In this session, we will quickly revise all the topics of grade 12 chemical kinetics chapter. I included all the different types of questions for this session which were repeated in previous NEET papers. This will help you to crack all the types of questions from this chapter with 100% confidence. And my dear students, once again welcome you all to the session. Be active, send your right answers in the comment box. We can start our session. Be active. So we will start our session. See, question number 1. This is based on the unit of rate. The question is, a gaseous reaction is given, A2 gives B plus 1 by 2C. That all the reactants and products are in gaseous state and shows increase in pressure from 100 mm to 120 mm. That means millimeter mercury. So 100 millimeter mercury to 120 millimeter Hg in 5 minutes. The rate of disappearance of A2 is, you know that one, here it is discussing with the pressure, not with the concentration. But the same way how we will be finding out for concentration, we can do this question. Let us listen. Okay, so here the reaction is A2 gives B plus 1 by 2C. This is our equation and this is in gas phase. All the reactants and products are in gas phase. See, here the initial pressure is given. When time t is equal to 0, we have 100 mm. When t is equal to 5 minutes, means after 5 minutes they are talking about. So after 5 minutes t is equal to 5 minutes, we know that one some molecule will transfer to right hand side. Then what we can write? We can write 100 minus x will be the pressure after a time t, that is 5 minutes. So after 5 minutes, the pressure can be taken as 100 minus x. We know that one, the total pressure we can consider here. B means 1b, the coefficient, then the pressure I can write after 5 minutes. This will attain an equilibrium, which means A2 will be there, B will be there, and 1 by 2C will be there. So B, the pressure we can write it as x, and here for C I will write 1 by 2x. Then what we can write, they gave the total pressure, means 100 millimeter to 120 mm is given. So the total pressure we can write it like this one, 100 minus x, okay, plus x, then plus 1 by 2x. Total pressure we can take it as 1 by 2x is equal to 120. Understood? So minus x plus x will be 0, then 100 plus 1 by 2x is equal to 120, okay, is equal to 120. From this one we can find out x. So 100 plus 1 by 2 x is equal to 120 means x value will be getting as what? This one will come to right hand side, then we will be getting 100 minus 120, then divided by 2, that will be 40. Now we are getting the value, x value as 40, correct? So that x value means you can substitute over here, that is the total pressure, because for rate of reaction we have an equation normally. What is? Rate is equal to d of concentration we will be taking normally. Here we will be taking P2 minus P1, isn't it? Divided by T2 minus T1 we can take. So T2 minus T1 anyway will be 5 minus 0. So here we can substitute the value is equal to D. P2 minus P1. P2 will be how much? Here you can see this is the P2, means final pressure. After a time T, the pressure is final pressure. X we got it as 40. So 100 minus 40 is what? 60. So here you will be getting the value. Here we can write d of P2 minus P1 is the final pressure minus initial pressure. Now we can substitute the value. This will be, in case of reactant it will be negative, that negative into negative anyway you will be getting positive, okay, minus d of, because we are considering the reactant, so it can be taken as minus d of P2 minus P1. You know that one, P2 will be how much? 60. 100 minus this one, x is 40. So 100 minus x is 60. So 60 minus 100 will come. That is the initial pressure. Okay. Anyway, minus is there outside and this will be 5 minutes. So 60 minus 100 is equal to minus 40. Minus 40 into minus, it will be plus. So 40 by 5 will come. Hope you understood. You can send your answer Yes, half is correct. So 40 by 5 is equal to 8 mm minute inverse. Why 8 mm minute inverse? Because here the pressure is taken in millimeter mercury. 40 by 5. So right answer is 8 mm minute inverse. Okay, so the only difference is that here they are talking about pressure. The remaining all is same only. Initial pressure they gave 100 mm. Then the final pressure after 5 minutes is 100 minus x. That x we can find out because initial and final pressure means the final pressure is given. So here it will be 100 minus x, that plus 1 by 2x is equal to total 120. From this one you can find out x value. 100 plus 1 by 2x means this 2 will go over here. Then you will be getting x is equal to 40. Okay, then you can substitute over here. 100 minus x is 60. That's 60. Final pressure minus initial. Final is 60 over here. 100 minus. So 60 minus 100, you will be getting minus 40. Minus 40. Outside there is a minus. Hope you understood. Now we will go to the second question. See, second question is for a gaseous reaction. This is the easy one. For a gaseous reaction, the rate of reaction may be expressed in the units. Normally, you know that one rate has a unit based on concentration. So what is the unit of rate based on concentration? You know that one, mole, liter raised to minus 1, second raised to minus 1, or you can write molar second inverse. So but in case of gaseous reaction, here they are talking about a gaseous reaction. So in case of a gaseous reaction, we can write rate is equal to, just before we wrote, d of pressure. Okay, so d of pressure divided by delta dt we can write. We can write dt. So d of pressure means just before we did P2 minus P1. So d of pressure divided by dt, which means pressure is, anyway here it is given in atm. So numerator we can take pressure in atm. Denominator it will be second. So second raised to minus 1. So atm second raised to minus 1 means here it is given atm slash second. Yes, correct is atm second inverse, or yes, half is. You can send your answer. Remaining all you guys should send your right answer in comment box. Yes, half is. Very good. Now we will go to, these are the type of question. These were the repeated question in the previous NEET papers. Okay, the same type based on pressure they asked. The third one, you know that one, for a hypothetical reaction 2A gives 3C. You know this is based on the rate expression. You know how to write rate expression for a reaction, but which one is the correct one? That is the question they are asking. So the equation is anyway 2 gives 3C. So 2A gives 3C. For this reaction, you know that one, R is equal to minus 1 by 2 D of concentration of A divided by dt equal to 1 by 3, because this is product side, D of concentration of C divided by dt will come. This is the way. So the right one is which one? Rate is equal to 1 by 3 d of 1 by 2 c minus 1 by 2 d of a divided by dt. This will not come because there is no coefficient, because here a has a coefficient 2. So this is the wrong one, this is the right one. This one anyway not, because 3 is for the right side. So correct option is B. It's a direct one. Yes, Reshma. Yeah, correct. Yeah, Abin. Yeah, well done. Good. So that is a one type of question. That's why we did this one. This type of one question you can expect. Sometimes it may be a simple one. Sometimes it may be a complicated reaction. It's anyway, logic is same. Now we will go to question number 4. Fourth one. For the reaction N2 plus 3H2 gives 2NH3, the rate of change of concentration for hydrogen is, it's given as minus 0.3 into 10 power minus 4 molar second inverse. Anyway, same only, because it's the rate of change of concentration for hydrogen. The rate of change of concentration for ammonia is how much? That is they are asking. This type of question also was there, okay, from this chapter. Let us see how to do this one. You know that one, here the equation is given as N2 plus 3H2 gives 2NH3. So they are talking about hydrogen, okay, rate of change of concentration, okay, for hydrogen. What is the rate of change of concentration of hydrogen? We can write like this one, d of H2, okay, divided by dt. d of H2 divided by dt is equal to minus. We know that one, this is the reactant side, so you can put minus. Minus d of H2 divided by dt will be plus. because rate of change of concentration of hydrogen means this one only, d of H2 divided by dt, that is positive. Positive plus d of H2 divided by dt is equal to minus, means minus d of H2 divided by dt will be what? 0.3 into 10 power minus 4. Okay, then you know that one rate is equal to what? You know that one rate is equal to 1 by 3 of this one. So rate is equal to 1 by 3 of this one means you know that one rate is equal to, okay, rate is equal to, this will be 1 by 3 into this one. Which one? 0.3. How that 1 by 3 came? Because when you write the expression rate equal to minus 1 by 3 d of H2. d of H2 divided by dt is the rate of change of concentration. Rate equal to 1 by 3 of that d of H2 divided by dt. So I can write 1 by 3 into 0.3 into 10 power minus 4. This is the rate. But they are asking what is the rate of change of concentration of NH3, ammonia. Now what we can write? Rate is equal to 1 by 2 d of concentration of NH3 divided by dt will come. This is the way we can relate according to the equation, because there is a quotient 2. So rate equal to 1 by 2 d of concentration of NH3 divided by dt. I will put this d of concentration of NH3 divided by dt over here. Then you know that one, this 2 will come to left side. Divided by 2 will be into 2. And here is the rate. So instead of rate, what I can write? 1 by 3 into 0.3 into 10 power minus 4. Again this 2 will come to right hand side as into. So this will be 2. You know that one, here it will be 0.3 into 0.2, this can be taken as 0.6, then divided by this will be 2. So 0.6 divided by this will be 0.2. Now it is 0.2 into 10 power minus 4. There will be answers here. 0.2 into 10 power minus 4. So right answer is option B. Yes, Sri. Yeah, correct. This question only you are sending, right? Yeah. So correct answer is 0.2 into 10 power minus 4, because we need to find out the rate. This is the rate of disappearance or rate of change of concentration of hydrogen. Positive equal to minus value, minus of this one is equal to plus value. From that one we can find out the rate, because rate is equal to 1 by 3 of this value. So we have this value, so I multiplied 1 by 3, we got rate. Now we have another relation, rate equal to 1 by 2 of this one. 2 when you take to left hand side, it will be into 2. So d of NH3 divided by dt, because that they are asking rate of change of concentration of ammonia, that is d of NH3 divided by dt. So I'll get 0.2 into 10 power minus 4, option is B. Hope you understood. Question number 5. A graph based question, but it's direct. The graph plotted between concentration versus time, you know that one, concentration versus time is called rate. Okay, rate of reaction. So concentration versus time, C1 and C2, final concentration C2, initial concentration C1 is given, final time T1 and T2 and T1 initial time are given. See, here they are asking which one is correct. Okay, so let us see. It gives the rate of disappearance of reactant. Yes, rate of disappearance of reactant is equal to, you know that one, for a reaction generally we will write rate is equal to, okay, minus D concentration of, we can take delta also, minus delta concentration of R divided by delta T. This is our equation according to a reactant. This can be expanded as minus of C2 minus C1 divided by T2 minus T1. That is the rate of disappearance of reactant. C2 minus C1 will give the change in concentration. T2 minus T1 will give you the change in time. So first is same anyway. I mean it's correct. It gives rate of disappearance of reactant. Next is what? Rate is equal to, that is the same only I wrote. Rate is equal to minus D of, or delta or D is same. C2 minus C1 divided by T2 minus T1. It predicts the order of the reaction. Never. Order is an experimentally determined quantity. From the plot or graph, we cannot find out or predict the order of reaction. So first one and second one are correct. So both A and B are correct. So right option is C. Okay, rate of disappearance of reactant, that is C2 minus C1 divided by T2 minus T1 is called rate of disappearance of reactant, and that when you divide, means calculate, you will get the rate. So correct answer is C. We can go to question number 6. See, question number 6 is the rate law of a reaction between the substance A and B is given by rate equal to K into A raised to N into A raised to M. it's a normal type, but read the question completely. On doubling the concentration of A and making the volume of B half. Normally the question is like A will be doubling, B will be doubling, or one will be double, the other will be keeping the same, or can be triplet. But here they are saying on doubling the concentration of A and making the volume of B half. What is the relationship between volume and concentration? We have an equation, concentration C is equal to N by V. So volume getting halved means concentration will be double. So the relationship between concentration and volume is inversely proportional. So when volume get halved, concentration will be double. So here indirectly they are saying volume of B half, which means concentration will be double. So what we can write? We have the rate law equation, K into A raised to N into B raised to M. Okay, these are the power. So they are saying doubling the concentration of A. So I can write 2A raised to N into B half the volume getting halved. In the sense concentration will be double. So again here also I will write 2B raised to M. So you know that one, A and B are for just for reactant and K is a constant. So I will get 2 raised to N, okay, plus 2 raised to M. So is equal to 2 raised to N plus M. Okay, 2 raised to N plus M. Correct option is C. Yes, very good, good. Half S, Reshma. Yeah, good. Saurav, well done. Chris, yeah. Good. Almost all you sent the right answer. So only this one you keep in mind. The volume when getting halved, the concentration will be double. Okay, fine. We can go to the next question. So question number 7. Consider a reaction 2A plus B gives C plus D if the rate expression is equal to rate expression are equal to A raised to 2 into B raised to 0, which means with respect to A the reaction is of second order, with respect to B the reaction is of 0 order, and if volume is reduced to 1 by 3, a fractional value is given. That's why I put this question. 1 by 3 is the volume decrease, which means what will be the concentration? It will be 3 times. Volume getting halved. 1 by 2 is the volume reducing, means double will be the concentration. 1 by 3 is the volume decrease, means 3 might be the concentration change. 3 times. The rate of reaction will be same type, but the fraction value gave. Small letter r is equal to K into concentration of A raised to 2 into B raised to 0. You have to take both. One is 0 order, that you keep in mind. So K equal to what you will get, 3A raised to 2 will come. Again here also will come because volume will be applicable for both. Okay, so 3B raised to 0 is equal to K and AB are reactant. So 3 square is equal to 9 into here it will be 3 raised to 0 is equal to 1. So it's equal to 9 times. Okay, 9 times. So correct answer is B. Yeah, 7 is B. Well done. Half is, yes, 7th one is B, 9 times. So these are the logical question and the same type of question you can expect from this chapter, chemical kinetics. We will go to question number 8. See, this is the another type for 0 order. For a 0 order reaction, K equal to rate constant has given. What is the rate constant value? 1 into 10 power minus 3 mole liter raised to minus 1, second raised to minus 1. Rate constant has the same unit of rate in 0 order. So if initial concentration of the reactant is 1 mole liter raised to minus 1, the concentration after 10 minutes. 0 order reaction, they are asking how much a concentration will be there after 10 minutes. So what you need to calculate? Final concentration. So we have an equation in 0 order reaction, that is R0 minus concentration of R divided by T is equal to K, or you can write is equal to KT, same only. R0 minus concentration of R is equal to KT. Then R0 has given how much? 1 minus concentration of R is equal to K has given how much? 1 into 10 power minus 3 into time has given how much? It is 10 minutes. But you keep in mind here K is in which unit? Second inverse. K, the unit of K has given in second inverse. So the time you should convert into seconds. So I will multiply 60 over here. Okay, so I can write 1 minus R concentration, that is the final concentration, is equal to 10 power minus 3 into this one. This will be 10 into 60 will be 600. 600 into 10 power minus 3 can be written as 0.6. Hope you got. 600 into 10 power minus 3 will be 0.6. Now we can take minus concentration of R to right hand side. It will be plus concentration of R is equal to 1 minus. Okay, this can be taken to left. This, so 1 minus, you know that one. 1 minus 0.6 is equal to 0.4 over. Final concentration is equal to 0.4. Yeah, right answer is there, option C. Okay, so this is the way you need to solve. So this is the another category question to find out the final concentration for zero order. Yeah, half is correct. And Sriya, yes, Saurav, well done, well done. Yes, Reshma, yeah. Better you can send the question number also while sending your right answer. I don't know whether you are sending for the previous one or the current question. So better you add the question number also. That would be better. Fine. Yes, Saurav. Yeah, good. So for the for this one, correct answer is this one. Now we will go to question number 9. Okay. So for the 9th one, the inversion of cane sugar represented by, you know that one, yeah, C12H22O11 plus H2O gives C6H12O6 plus C6H12O6. This reaction we learned, okay, C12H22O11 when added with water. This is liquid and we will take this water in excess concentration. Okay, we discussed one type of question. The same type of question you will be getting glucose and fructose over here. See, in this reaction, you know that one, this is pseudo first order reaction as well as pseudo unimolecular. So pseudo first order means first order reaction only. This never be a unimolecular reaction. This is a pseudo unimolecular because concentration of water is excess. So that this will be neglecting. You can call it as pseudo unimolecular, not unimolecular. This is not in second order because water in excess concentration. So concentration change of water is negligible. So what is the right answer for this one? Yes, well done, well done. Everyone are sending the right answer. Good, good. Correct option is D. Yes, this is a first order reaction and the same we learned as a example for pseudo order reaction. We have only one pseudo order reaction in our syllabus, that is pseudo first order. So this is pseudo first order reaction because water concentration is excess. When the concentration of water is excess, concentration change is negligible and the value is taken as unity. Okay, so correct answer is first order. Okay, we will go to question number 10. See, this is based on a graph or a plot. Okay, for a first order reaction, straight line is obtained. Okay, if you plot, you know that one. For zero order and first order, we have some plot, means graph based question. For first order reaction, always you keep in mind, for first order reaction, we have log concentration, that is ln R concentration, log concentration versus time will be a straight line. Okay, straight line with the negative slope. For zero order reaction it will be, okay, for zero order reaction, you know that one, we discuss this type of question. For zero order reaction, concentration versus time will be a straight line. Okay, straight line with the negative slope. So here they are asking log concentration of R, that will be, that can be ln or log, because we have an equation for first order reaction. We have an equation, you know that one, we can write K is equal to 2.03 divided by T log concentration of R0 divided by R. This equation when you rearrange, you will get KT divided by 2.03 is equal to log concentration of R0 minus log concentration of R. I will write directly, okay, anyway the step. So log concentration of R is equal to minus K divided by 2.03 into T plus log R0 will come. Why we are writing like this one? Because that equation is in the form of equation of straight line, that is y equal to, okay, now this equation is equal to equation of straight line y equal to mx plus c. Y axis you are taking log concentration of R, x axis you are taking time, then it will be a straight line with a negative slope. So always log concentration versus time for first order reaction, it will be a straight line. So log concentration of reactant versus time will be a straight line, okay, always for first order reaction. Yes, good, good. Yes, answer is A. Well done, well done. So we can go for the next question, better we can do almost all type of question, that would be better. So this is anyway you understood. For zero order reaction, this one you keep in mind, concentration versus time. Now we'll go to question number 11. So the 11th one is the graph of T half versus initial concentration of A is. We know that one, there is a difference between half-life period of first order and half-life period of zero order. What is the difference between half-life of zero order and half-life of first order? T half or half-life of zero order reaction directly depend upon initial concentration of reactant. Here what is A? A is the initial concentration of reactant. You know that one, this is initial concentration of reactant. So initial concentration, T half versus initial concentration. For zero order reaction, we have an equation for T half. T half is equal to R0 divided by 2K, which means when initial concentration increases, T half increases. This is for zero order. But for first order, we have an equation that is T half is equal to 0.693 divided by K. So 0.693 divided by K means it is independent. T half is independent of initial concentration of reactant. So here that is given. Whatever the initial concentration, okay, irrespective of the concentration of reactant, we can say generally T half remains the same. So the order in which T half remains same is first order. So only in first order T half is independent of initial concentration. So correct answer is option A, first order. Yeah, 11th one, all are sending right answer. Yes, correct, A. So graph based question also you can expect. Yeah, here the good. Okay, so all are sending right answer. Now we will go to question number 12. So 12th one is a first order reaction completes 60% in 20 minutes. The time required for the completion of 90% of the reaction is approximately. So in this one, the first part they are giving the hint to find the K value. Okay, so a first order reaction completes 60% in 20 minutes. So we know that one K, we have an equation. What is K? K is equal to 2.03 by T log R0 divided by R. So 60% is completed means only 40 remains. Okay, keep in mind. So we can write is equal to 2.03 divided by, what is the time? 20. Okay, into log 100 divided by 40 will come. Okay, log 100 by 40 will come. So it's equal to 2.03 divided by 20 into log 10 by 4 is equal to 5 by 2, or you can take it as log 10 minus log 4. Let us check which will be easy. Log 10 minus log 4 it will be. After that, what they are asking, what is the T 99% completion? So T 99% completion means, you know that one, T 90% completion is equal to 2.03 divided by K. Okay, log, here it will be, yeah, so this will be log 5 by 2 you can take, and here it will be log, what will come, 90% means 100 divided by 10. Okay, so 100 divided by 10, 90%. So it will be log 10, 1. So we need to substitute the K value. So 2.03 divided by, here this will be log 10, 1. So 2.03 K value you can substitute. So here if you want you can substitute the value, log 10 is 1. Okay, so here I will write 2.03 divided by 20 into log 10 is 1, 1 minus 0.60, which means 0.4. So what will come in the denominator? So here I can write is equal to 2.03 divided by 20 into this value they will give in the bracket. Log 4 is 0.6021, 0.60 you take. So 1 minus 0.60 is 0.40. So K value you can take it as divided by 2.03, okay, into 20. You can take to the numerator, okay, and is equal to 0.40. Now 2.03 cancel. You know that one, 20 divided by 0.4. How much it will be? Yes, correct answer is 50. Understood, right? This can be written as 200 by 4, correct only, 200 by 4. Anyway, 50. Yes, well done. So should not solve this K value completely. That's what I wrote. You can check with the next value. Better to write it as 10 minus 4 or 10 by 5, 5 by 2, which would be better, that you will get once you write the equation of T90. So T90 anyway 2.03 by K. So you can write like this one, 1 minus 0.60. This value we can take it over here. Then you will be getting 20 divided by 0.4, that is 200 by 4 is equal to 50. That's the way. Okay. Now we will go to question number 30. Okay. The half-life period of a substance is 50 minutes. Yeah, this is a different type of question. Listen carefully. This type of questions was also there in the previous NEET paper. The half-life period of a substance is 50 minutes at a certain initial concentration. When the concentration is reduced to 1/2, half-life is found to be 20 minutes. So, 2 half-life has given. We can write T 1 by 2, 1. First half-life is how much? 50 minutes. So, T 1 by 2, 2. Second half-life is given. That is how much? 25 minutes. Correct, right? Yeah. Order of the reaction is. So how would you relate T half and order? We have a relation that is T half proportional R0 in R0 raised to 1 minus n. Then T half 1 and T half 2 means we can write the equation like this one. You know that one where n is the order of the reaction. So here they are asking order of. So where n is order of reaction. Keep in mind. So when you are substituting for 0 means for 0 order, you know that one 1 minus 0, it will be 1, because 0 order reaction T half is directly proportional to initial concentration. For first order means you know that one 1 minus 1, 0 will come, R0 raised to 0 is 1, which means T half is independent of initial concentration. So this equation you keep in mind, it is important. T half proportional R0 initial concentration raised to 1 minus n. So if 2 half-lives are given means you can write like this one, T 1 by 2 1 divided by T 1 by 2 2 is equal to R0 1 means the first one, okay, divided by R0 2 whole raised to 1 minus n. You can write these two values are given. What is that? 50 divided by 25 equal to, here they are giving the hint, the half-life period of a substance is 50 minutes at a certain initial concentration. They did not give the initial concentration, so let us take it as R0, or you can write it as A or A0, whatever it is. A I will write. But the second one they gave the hint. For the second one, concentration, when the concentration is reduced to 1/2, initially what we took, the first one let it be A, then the second one will be what? 1 by 2 of A, then whole raised to what will come? 1 minus n. Hope you got. A divided by 1 by 2 of A. 50 by 25 can be written as what? 2. A divided by 1 by 2 of A will be coming as A divided by A into 2 will come to numerator. So you can cut A and A over here. Okay, because A is in the denominator. So A will be cancelling. Then you will be getting 2 raised to 1 by n. Sorry, 1 minus n. So 2 equal to 2 raised to 1 minus n means that you know that one, that is n value should be 0. Because 1 minus 0 is 1, 2 raised to 1 is 2. Now we got n equal to 0, which means 0 order reaction. 0 order reaction. Question number 13. I think Hafiz got, Saurav, Abin Abdul Salim. Oh, good. Yes, only 3 ways. Yeah, 3 gave the right answer. This question, do carefully. This question was there, or this type of question was there in previous NEET papers. So the value will be coming like this one. This relation you keep in mind, T half always, because when you substitute n equal to 0, you will get the relation for 0 order. 1 if you are substituting, we know that one, it is independent of initial concentration, R0 value will be 1. This equation you keep in mind, this type of one question you can expect. Now we will go to question number 14. Yes, 14th one. A sample of a radioactive substance undergoes 80% decomposition in 345 minutes. So a sample of a radioactive substance undergoes 80% decomposition in 345 minutes. Its half-life is dash minutes. So what they are asking to calculate T half, and you know that one, every radioactive reactions comes under first order. So you can use you can take the K value, because T half means it is 0.693. T half equation is 0.693 divided by K. And we have, in terms of K, if you are writing, you know that one, K is equal to 0.693 divided by T half. Anyway, T half is equal to, you can equate, that's why the way we can write. So K is equal to 0.693 divided by T half. Because we have an equation K equal to K is equal to 2.03 by T. Okay, log R0 divided by R. From this one we need to find out the K value first, because 80% decomposition, which means we can write 2.03 by T. T is 345. Okay, no need to solve completely, I'll tell you, because here the value is given in this way. You can do and send the right answer. 2.03 divided by 345 into log, what is the value? R0 is 100, 100 divided by 20 will come. So 10 by 2 will be log 5. And what I will write is equal to 2.03 divided by 345 into log 5 will come. Okay. This K can be substituted. What we can substitute K? K is equal to 0.693 divided by T half. Yes or no? T half. But in the answer you check, this type of question you have to go with the, you have to check with the option, then only you have to solve accordingly. Otherwise you will be in trouble, because log 2, log 5, log 5, log 2, log 4, that means in the answer 2 log values are there. But when we are solving now, we have only one log value, which means one of the value we need to change it as log. That is the question. Okay. Listen, I'll tell you. See, when we derive the equation 0.693 by T half, we got the value actually as 0.693, as how the 0.693 value came. 0.693 is nothing but it is 2.03 into, okay, 2.03 into what? Log 2. Yes or no? Because log 2 is 0.3010. 2.03 into 0.3010 is 0.693. So I can substitute this one. 0.693 I will substitute. What I can write? 2.03 into log 2 divided by T half, okay, is equal to 2.03 divided by 345. Okay, so 345 into log 5 will come. Hope you got. Now 2.03, 2.03 can be cancelled. Now you can cross multiply and write. It's same way, answer is there, I think. So what is the answer for what they are asking? T half. Yes. So what will come for T half? T half is equal to, so what will come? Log 2. Okay. So this will be, you can cross multiply the value. This will be in the numerator, log 5. So it will be 345 into, okay, log 2 divided by log 5 will come. Correct, right? Log 2 divided by log 5. So option is A. All you got? Question number 14A. Well done. 14A. So cross multiply T half into log 5, okay, is equal to log 2 into 345. So when you take log 5, log 2 divided by log 5. You will be thinking that here it is ln. It's same only. Log 2 by log 5, you can write it in that one also, it's same. 345 into ln 2. Natural log 2 divided by natural log 5 is also same only. Nothing different. For converting into base 10 and taking the value, we are converting. Anyway, logically that is same. Is equal to 345 into log 2 divided by log 5. So correct option is A. Okay. Now question 15. Yes. Question number 15. The chemical reaction in which reactants require high amount of activation energy are generally. The last few questions were completely numerical. Now this is a theoretical one, so you can relax with the question. Now you tell. I will wait for your answer. This one you should tell. It's anyway, it's a direct question. Yes. The chemical reaction in which the reactants require high amount of activation energy are generally. What is the relationship between activation energy and rate of reaction? There is a statement, higher the value of EA, okay, higher the value of EA, activation energy, lesser the speed, okay, so rate of reaction will be less, which means a slow reaction. activation energy EA when increases, okay, rate of reaction decreases. This is the relation. EA, not directly proportional. EA when increases, rate of reaction will less, because higher activation energy means more energy we need to supply, then only reactant molecule will get threshold energy. It takes time, or more energy we need to supply, then the rate of reaction will be less, because less molecule will get activation energy means number of effective collisions will be less. Yes, Hiba, well done. So correct answer is A, reaction will be slow. It was a direct question. Now question number 16. Yes, so another question based on graph. For the chemical process, energies are plotted in graph. You know that one here, A converted to B, a reaction is given. Okay, we know that one, there is a equation delta H, enthalpy change is equal to EA of forward reaction minus activation energy of forward minus activation energy of backward. Whenever delta H value is equal to negative, it's called exothermic. You know that one here, energy of forward, okay, is less, because here is the value, energy is less. Energy of forward means this one, product. So product minus reactant. So product has less energy, or forward has less energy. Backward has more energy. So definitely lesser value minus higher value, it will be negative. So the graph given for an exothermic reaction, it is exothermic reaction, delta H is equal to B minus A, same only. B is the product, A is the reactant. So B minus A, correct. Threshold energy, you know that one, this is the threshold energy level. Threshold energy level is equal to E. E equal to A plus C, correct. Threshold energy is equal to E equal to A plus C. Yes, options are coming, well done. Abin, half is, yes. Threshold energy is equal to this one, EA of forward less than EA of backward. Yes, backward the energy is more, that is why it became an exothermic reaction. If it is opposite, then it will be an endothermic. So all these are correct, option is D. So graph based question you can expect, yes, Hiba, option is D. So question number 16. Now we can do question number 17. Read the question number 17. The rate of a reaction becomes 2 times for every 10 degree rise in temperature. Yeah, this type of one question, you know that one. Arrhenius introduced an equation, a mathematical relationship between rate constant and temperature. That means it has been proved that for every 10 degree rise in temperature, rate of reaction become double. So you know that one, for every 10 degree rise in temperature. Okay, so every 10 degree rise in temperature, we can write rate of reaction will be double, which means you have to write it as 2 raised to n. 1 10 degrees there means 2 raised to 1 will come, 10 degrees are there means you will get 2 raised to 2, like that. Here they are telling 10 degrees Celsius rise, and from where the temperature has been raised, increased from 30 to 80 degrees Celsius. So 30 to 80 degrees Celsius, which means the difference is 50 degree. 50 degree means 5 tenths are there. So there 5 tenths. 5 tenths means you can write 2 raised to 5. 2 raised to 5 is equal to how much? 32. Yes or no? Yes, correct answer. Half is, yeah, for every 10 degree rise in temperature, rate of reaction will be double, which means it's like a fold, 2 raised to n. So 30 to 80 degree then is equal to that, the difference is 50 degree. 50 degree means 5 tenths are there. For 1 10 degree, 2 raised to 1. So 5 10 degree, 2 raised to 5. 2 raised to 5 will be 32. Correct answer is option B. Okay. Now we will go to question number 18. It's a direct question. Yes. Now this question you can do and send your right answer in comment box. Let's see who all will do the question. It's a direct one. Send your answer fast. Don't waste the time. While reading itself, you will get the option. Yes, everyone, hello. Send your answer. The minimum amount of energy that the reacting molecules must possess at the time of collisions in order to produce effective collision is called. Yes, yes, come on, send. Yeah, fine. Only few people are sending. Yes, remaining all you send. It's a right direct question. So what is the minimum amount of kinetic energy that reactant molecule should possess to participate in a chemical reaction, that is called threshold energy. The minimum amount of kinetic energy that every reactant molecule should possess to participate or to make effective collisions in a chemical reaction, which will determine the rate of chemical reaction. So correct answer is threshold energy. So if molecules are not having threshold energy, then we must supply extra amount of energy, that is called activation energy. So here the right answer is option B, threshold energy. Good, well done. Yeah, almost all sent. Now we can go to question number 19. Yeah, this type of one question they repeatedly asked in so many previous NEET papers. Nitric oxide NO reacts with oxygen to produce nitrogen dioxide. Equation has given 2NO plus O2 gives 2NO2. If the mechanism of reaction is like this, you know that one, step 1 is given NO plus O2 reversibly is NO3, but that is a fast reaction. Reversible means we can apply equilibrium constant, that's why they mention it's a fast but reversible. Second one is a slow step, NO3 plus NO K1, we can write NO2 plus NO2, that is a slow step. Why they mentioned the slow step means rate low can be applied only in the slow step. So here we will apply, so here we can apply, this is the rate determining step. Okay, this is the rate determining step. In the rate determining step, we can write the rate law first. Small letter r equal to K into reactants are NO3 concentration into NO concentration. We don't know the actual power. So here if you, this is the K1 we can write. See, but in the fast reaction, the reversible reaction, what we can apply? The equilibrium constant, I will write K or Kc, same only, K is equal to, right hand side I have NO3 concentration divided by, in the denominator it will come NO2 concentration into O2 concentration. So what I will do, I will write in terms of NO3 because here I can substitute NO3. So if you are writing this equation in terms of NO3, NO3 concentration is equal to, NO3 concentration is equal to, okay, K into NO2 concentration into O2 concentration will come. So what I can do is, here I can substitute NO3. Already there is a K and here also K is there. That is the equilibrium constant, anyway, constant only. So instead of this NO3, I will write K into NO2 concentration into O2 concentration, and already there is a NO2 or NO. It is slow step. Small letter r is equal to K into NO2 concentration. Here where is the step? Yeah, fast reaction NO it is. By mistake I wrote NO2 over here. That is the, yes. So here it is O2 concentration. Listen, NO3 concentration divided by NO concentration into O2 concentration, not NO2. Yeah, NO concentration into O2 concentration. Fine. That is the equilibrium. Now we can substitute over here. Okay. So NO3 I substituted as NO. Okay, NO concentration. So I will write NO concentration into O2 concentration, and again one NO is here in the default equation. K into K means nothing but you can take it as a new rate constant, that is K dash. Anyway, same only. NO concentration, I will take it as NO raised to 2 into O2 concentration. O2 raised to 1 anyway, it's a default. So K dash or K is the same rate constant only. So correct equation is here, see given. So K dash into NO2 raised to 2 into O2 concentration. So our correct answer is option C. Yeah, this type of one question we discussed today, it's same. So K dash into NO2 concentration raised to 2 divided by O2 concentration. Okay, so we will go to question number 20. Hope you understood this one. See, question number 20 is another different one. A first order reaction, the time taken to reduce the initial concentration to a factor of 1/4 is 10 minutes. So for a first order reaction, time taken to reduce the initial concentration to a factor of 1/4. To a factor of 1/4 is 10 minutes, means we can write like this one. Time taken to reduce the initial concentration. So we can write like this one, K. In terms of K, if you are writing, I'll get 2.03 divided by 10 minutes, okay, into 2.03 by T log, what they are saying, 1/4 of initial they are saying, okay, reduce the initial concentration to a factor of 1/4, which means I can write A divided by 1/4A. If A is the initial, means 1/4 A will be there, reduced to. Okay, this can be taken as equation number 1. Again, they are giving the second condition, that's why you can equate, that would be better. The concentration, again they are saying reduced to 1/6, then the time required. So the second one I can write like this one, K equal to 2.03 by here time we need to calculate, T we need to calculate, log A is initial means 1/16 of A. This is equation number 2. So what we can write, equate over here. So left hand sides are same, so I can write 2.03 will be cancelling. So I can write 1/t. I'll write this one first. 1/t log 16. A will be cancelled, 16 will come numerator. So 1/t log 16 is equal to, this will come now 1/10 log 4 will come. A cancel, log 4. Hope you got. Then again I can write 1/t log 16 can be written as what? Log 4 square, correct? Log 4 square is equal to 1/10 log 4. So log 4 square can be expanded as 1/t 2 into log 4 is equal to 1/10 into log 4. Okay, so log 4 can be cancelled. So log 4. So what will you get? 1/t into 2 is equal to 1/10. So what is t they are asking? So how much is the t? Tell. What you got? 19th one. Yes, it will be. Yes, answer is 20 minutes, right? Yes, Hiba, correct. So t time they are asking 2 into 10. So is equal to 20 minutes. It's easy, better to equate. This type of one question you can expect. So correct answer is 20 minutes. Half is good, well done. 20 minutes. So this one you can equate. So 4 square we wrote 16, then 2 log 4 can you cancel, t is equal to 20 minutes. We will go to question number 21. Which of the following is correct? Read the question carefully. This type of, I told you that assertion reason type or this type of theoretical question will come, which one is correct, incorrect, okay, which statement support the other one, that type of question. Some of the question may be a bit lengthy one, so prepare for that. So which of the following is correct? Log k2 by k1 is equal to EA divided by 2.03 into delta t divided by t1 t2. Is that equation is correct? One factor is missing. Which is the factor missing over there? Other than everything is correct. Log k2 by k1 equal to EA divided by 2.03. R should be there. R into delta t, it's correct only. T2 minus t1 divided by t1 t2, no issue. So R is missing, so anyway, so it is not correct. If R is there means, okay, we can say it is correct. This is the wrong one. For zero order reaction, T half is inversely proportional to initial concentration. No, for zero order reaction, T half is directly proportional to initial concentration. T half is equal to R0 divided by 2K. So if you double the initial concentration, T half becomes double. So directly proportional. Statement third one is wrong. Catalyst decreases the activation energy. Correct. The role, the function of a catalyst is to provide an alternate path for the chemical reaction by lowering the activation energy. So whenever you add a catalyst, it does not change the Gibbs free energy of the reaction or anything other, but it decreases the activation energy of the reactant molecule, means more molecule can acquire activation energy easily. So correct, and this is the correct one. Catalyst decreases the activation energy. All of this anyway cannot. Yes, correct one is C. Okay, so we will go to question number 22. The rate constant of a first order, the rate constant of a reaction is anyway first order only 1.5 into 10 power 7 second inverse at 50 degrees Celsius and 4.5 into 10 power 7 second inverse at 100 degrees Celsius. What is the value of activation energy? Just before we got an question in that one, there is an equation for activation energy. What is that? Log k2 by k1. This one also you need to practice. This type of question they can ask. Log k2 by k1 is equal to EA divided by 2.03 R into 1 by T1 minus 1 by T2. This is our equation. Here temperature is given. T1 is 50 degrees Celsius, so 50 plus 273 you should take. T2 is equal to, how much is the second temperature? That is 100 degrees Celsius, so 100 plus 273. Okay. So this value you should substitute over here, log K2 by K1. It's given directly. So log K2 value is how much? The second value 4.5. So 4.5 into 10 power 7 divided by 1.5 into 10 power 7. Also equal to EA divided by, this value always you keep in mind, 2.03 into, okay, 8.314. That will be 19.141 into temperature is T2 minus T1. You can take the value 50, okay, plus 273, 300. This one will be here. So is equal to 323, right? Divided by, here it will be 373. So 50 difference will be there anyway. 50 divided by, denominator will be T1, T2. So it will be 323 into 373. That you solve. Here anyway, you can solve the value easily. 10 power 7 will be cancelled. Here it will be 3. So it will be log 3 is equal to EA divided by, this will be 19.141 value always. 19.141 into 50 divided by this value to 323 into 373. That value. Then you can take the EA. So EA is equal to log 3 is 0.4771 into 19.141. okay, this will be all the value. Then this one you can multiply into 50 divided by 323 into 373. That value you have to solve. Clear? So this will be the answer. You have to solve this one. Right answer will be I think around 2.2 into 10 power 4 will come. Solve and check. This was the previous board question, previous NEET question. So this one 2.2 into 10 power 4 joule mole raised to minus 1 will come. This is the way you solve 19.141 and you can multiply and divide. Okay, let us check the answer, the correct one you are getting or not. Now we will go to the next one, 23. Few more questions are there. We can do activation energy EA and the rate constant K1 and K2. This is about the equation what we wrote, but read the question carefully. This was the one question from previous NEET paper. See, log K2, ln or log I told you it's same only. Log K2 divided by K1 is equal to EA divided by 2.03 will not be there. If it is ln, that's it. Anyway, minus is not there. This is wrong. 1 by T1 minus 1 by 2 is correct. Everything is correct, but negative is there. So this is the wrong one. Okay, so that is the wrong one. This is the wrong one. We can go to the C. Log K2 by K1 is equal to EA divided by R into 1 by T1 plus 1 by T2. Wrong. What about the D1? I'll go to the D1. After that I'll tell you, because here two answers are coming. It was there the same question. Anyway, two options. The right answer won't be there, but this was the question. Okay, and from this one, if you are writing this one or this one, you will get the mark. Here both the equations are correct, and that question, listen, D, log K2 by K1 is equal to EA divided by R into 1 by T1 minus 1 by T2. This is the right one. Okay, not only this one is also right. Why? Log K2 by K1 is equal to minus, when you are putting, this can be reverse. 1 by T2 minus 1 by T1 I am taking, but here it is negative. This can also be right. Anyway, only one option will be there. Otherwise, the option they will give in the next one as both B and D. The same, log K2 by K1 equal to minus EA divided by R into 1 by T1 minus 1 by T2, or EA divided by R into. Okay, that you keep in mind just to give you the idea. These both can work, means both can use in the same way. Okay, now question number 24. Okay, we have two more questions. We will finish this one. That would be better. See, question number 24 is half-life for radioactive carbon 14 is 5760 years. 5760 years. How many years 200 milligram of carbon 14 will be reduced to 25 milligram? Every radioactive reactions are of first order. They are asking to calculate the time. We have the equation time T is equal to 2.303 divided by K. Okay, log R0 divided by R. Substitute the value. Here milligram no need to convert, because initial milligram and final also milligram. So you can take the same, no problem. Now when you substitute the value, time they are asking is equal to 2.03 divided by, what is the K value come? First order reaction we have an equation, no, T half is equal to 0.693 divided by K. So what is K? K equal to 0.693 divided by K value has T half is given 5760 years. So 5760 years, that value. So you can take it over here. So it will be 0.693. Okay, into that 5760 will come to the numerator, into log what will come, 200. 200 is given, right? Yes, log 200 divided by what will come, 25. So you can easily solve, I think, is equal to 2.03 divided by 0.693 into 5760 into log 80 will come. Okay, 200 by 25 is equal to 8. So it's equal to 2.303 into 5760. Okay, 0.693 divided by 60 divided by 0.693 into log 8 can be written as log 4 square. So 2 log 4 will come. So 2.03 into 5760 into 2 log 4 divided by 0.693. Log 4 is 0.6021. Now you can solve the value. Okay, this type of question will be there. So milligram means you can, both the values are milligram, so you can keep it the same. So log 8, this value you need to solve, 57360 years, that is the value of K. You can substitute over here, 2.03 by 0.693. 2.03 and 0.693 you can cancel. So you will be getting 0.3010. Kaushik. Oh, sorry, yeah, here, wait, yeah. Here it is not 4 square, it is 2 raised to 3. I'm sorry. Yeah. So log 8 is coming, not 16. So it is log 8 means it will be log 2 raised to 3. Yes. So 2 log 3 will come. 3 log 2 will come. Yeah. Here there is a change. So log 2 raised to 3. So 5760 into 3 log 2. Yes, correct. Log. That you solve the value, you will get the answer. I think for this question, the right answer will be 17280 years. Check the value if it is correct or not. Okay, so the last and final, we will stop it over here. It's a different type of question. I'll take 2 minutes. After that we can wind up. A 300 gram radioactive sample has a half-life of 3 hours. After 18 hours, remaining quantity, you know that one, after n half-life, always keep in mind, after n half-life, okay, final concentration R is equal to, always you keep in mind, initial or initial concentration divided by 2, initial concentration into 1 by 2 whole raised to n. Okay, and initial concentration. So what we need to write is, here we need to find out what is n. N is the number of half-lives. So first you find out the number of half-lives. N half-life. Number of half-life can be written as. So number of half-life is equal to, total time is given 18 divided by, what will come? This can be written as, this equation can also be written as R0 divided by 2 raised to n. Both are same. So 18 divided by 3 is equal to what? 6. This is the number of half-lives where n is number of half-lives. So what I need to calculate final concentration only. So I can write final concentration R is equal to, initial has given very easy, 300 divided by 2 raised to, that is R0 divided by 2 raised to n. N is the number of half-life. Total time divided by number of half-life. See, sample has 3 hours. So 3 hours means total is 18. 3 hours is the half-life, means 18 by 3, 6. So 2 raised to 6 will come. I think 2 raised to 6 is 64, right? So 300 divided by 64 will come. So 300 divided by 2 raised to 6 is 64. I think the answer is 4.68. Yes, Hiba, correct. Okay, fine. This is the right answer. So all the 25 question, all the types of question, all questions were repeating in previous NEET papers. So all these questions are over. Practice it and understand the logic. The same type of question you can expect in the upcoming NEET exam. And my dear students, see you on the next session. Thank you for watching. See you on next session. Bye.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.